Hello. I'm going to talk about carrier concentration. According to Hall effect, we can solve carrier concentration and another carrier solution has another solution. Uh, Carrier concentration uh, to solve carrier concentration, we can solve uh, density of states and Fermi drug distribution. The density of state is available state and function of energy, and a Fermi drug distribution is a probability of occupancy. So, uh, density of density of state is uh, volume and energy, function of volume and energy. First, one D one di one dimension uh one dimension or density of states is uh this equation. So density of states is proposed to energy to the minus minus 1 hertz, and two two dimension 2D uh is 2D density of state is this equation. This equation is constant, so is not function of energy. And like 3D or three dimensions density of state is this equation. This equation uh density of state is proportional to energy to energy to the 1 hertz. So uh 3D dimension 3D the this density of state is graph, and this graph is 2D, this graph is 1D, and this graph is uh one atom. And so uh, conduct band at conduct band the density of state is this graph, and valence band density of state is this graph. So we're gonna talk about Fermi-Dirac distribution. Fermi-Dirac distribution is probability of occupancy. Fermi-Dirac distribution equation is this equation. Is for electron. Uh, Fermi we to solve Fermi Dirac distribution, we can we we have to know Fermi energy level EF and temperature. This graph this graph is Fermi Dirac distribution. Uh, F 1 Kelvin. This graph, and at 290 Kelvin. This graph, and at 1000 Kelvin. This graph. So, uh, this one or occupancy one is just uh, one, and this is zero. And for whole, whole Fermi drug distribution is one minus electron Fermi Fermi-Dirac distribution. And we can solve electron and hole distribution with energy. Uh, Electron and hole distribution with energy is uh, density of states is DOS times Fermi-Dirac distribution FD. So uh, electron electron distribution equals uh, SE times FE, and uh, PE for whole distribution SE times F whole FE. So we can we, we can see this graph. Purple graph is uh, electrons and holes distribution. Uh, we can we can talk we can talk this this graph is Boltzmann pair. Boltzmann pair is Boltzmann pair, and this area is carrier concentration. So, uh, electron, free electron is equals integral and conduction energy to infinity. Uh, Density of states times electron Fermi-Dirac distribution dE is uh, integral conduction band to the infinity and electron distribution dE. Oh, whole equal whole concentration equal integral minus the infinity to balance band the density of state times force Fermi-Dirac distribution dE. So equal integral minus infinity to balance band uh, minus infinity to the balance band of force distribution dE. At 3D, uh, we leave 3D for uh, density of states for hole is this equation, and for electron and density of states for hole this equation. So and n0 electron concentration equals NC exponential minus exponential minus conduction band minus Fermi energy level over KBT. So KB is Boltzmann constant, and whole concentration equals MV times exponential minus Fermi Fermi energy level minus balance band over KBT. So NC and MV, or we can talk effective density of state. So from mass action law, N0 times P0 equals Ni squared. So Ni squared equals NC times MV to the minus one half and times exponential minus 1/2 energy gap over kBt. So Ni is Ni is function of temperature. So Ni is proportional to exponential heat. For intrinsic semiconductor, N0 equals P0. So Fermi energy level and intrinsic energy level equal. So intrinsic energy level equal uh, con energy band gap plus 3/4 kb times kbt times ln ln uh, mass of hole over mass of electron. So room temperature is uh 290 Kelvin. So at 290 Kelvin, uh intrinsic energy level is not mid gap mid gap mid gap, and uh for intrinsic condition, n0 equals ni and t0 equals ni. So uh n0 equals ni times exponential of Fermi energy level minus intrinsic energy level over kBt, and P0 is uh, this equation. So we can solve Fermi energy level minus intrinsic energy level uh, equals kBt times ln n0 over ni. And uh, for whole energy intrinsic energy level minus Fermi energy level equals kBt ln P0 over ni. And for in extrinsic semiconductor, uh, intrinsic extrinsic semiconductor is has doping. So, at anti-semiconductor, N0 equals Ni plus large ND. Ni, normally, Ni is 10 to the 10 to the 10, but large ND is uh, 10 to the 15 and 10 to the 18. So, ND is uh, is big, bigger than Ni. So N0 equals ND. Whole for for two. If semiconductor is stopped by both donor and acceptor, N0 equals ND minus NA and P0 equals NA minus ND. But ND is larger than NA. is N0 is ND. And or P0 at P0 and at P type or NA is larger than ND, or P0 equals NA. Oh, thank you.